Hello everyone, welcome back to my YouTube channel. I am Purnima and I'm from Sri Venkateshwara College of Engineering, Bengaluru, from the Department of CSE Data Science. Now, in this video, we are going to discuss about the basis and dimensions of vector space. Introduction. Vector spaces are fundamental mathematical structures used in various fields such as linear algebra, physics, and computer science. The basis and dimensions of a vector space play a crucial role in understanding its structure and properties. This presentation will provide a comprehensive overview of basis and dimensions in vector spaces. Let us know what is vector spaces. A vector space is a set of vectors closed under addition and scalar multiplication. It satisfies several axioms, including the existence of zero vector, additive inverses, and distributive properties. Examples of vector spaces include R power n, where n is dimensional Euclidean space and the space of polynomials. Next, the basis of a vector space. The basis of a vector space is a set of vectors that spans the entire space and is linearly independent. A spanning set is a set of vectors that can generate all vectors in a space through linear combination. A basis provides a unique representation for each vector in the space. Now, let us know what is linear independence. A set of vectors is linearly independent if no vector in the set can be expressed as a linear combination of the other vectors. Geometrically, linear independence means that no vector lies on the same line or plane as the others. Linear independence is crucial in forming a basis for a vector space. Next, spanning set. Spanning set is a set of vectors that can generate all vectors in a vector space through linear combinations. Geometrically, a spanning set fills the entire vector space. A basis is a minimal spanning set, meaning it contains the fewest possible vectors needed to span the space. Let us know the dimensions of a vector space. The dimension of a vector space is the number of vectors in its basis. It represents the maximum number of linearly independent vectors that can exist in the space. The dimensions also determines the number of coordinates required to uniquely represent a vector. For example, R squared. The vector space R squared represents points in a 2D plane. Any two linearly independent vectors such as 0, 1 and 1, 0 form a basis for R squared. Therefore, the dimensions of R squared is 2. Next example is R cube. The vector space R cube represents points in 3D space. Any three linearly independent vectors such as 1, 0, 0, 0, 1, 0 and 0, 0, 1 form a basis for R cube. Therefore, the dimensions of R cube is 3. Now, we'll know about basis and dimension theorem. The basis and dimension theorem states that any two bases of a vector space have the same number of vectors. This number is the dimension of the vector space. The theorem allows us to define the dimension of a vector space without explicitly knowing its basis. Uniqueness of bases. Every vector space has infinitely many bases. However, all bases of the same vector space have the same number of vectors, that is the same dimension. This property ensures the consistency of the dimension across different bases. Every vector space has a basis. Every vector in a vector space can be written in a unique way as a finite linear combination of the elements in the spaces. Hashtag of elements in a basis is dimension of a vector space. Changing basis. Changing the basis of a vector space involves expressing the vectors in terms of new set of basis vectors. This can be achieved through a change of basis matrix. Changing the basis does not change the dimension of the vector space. The next, basis extensions. Given a vector space with a basis of n vectors, it is possible to extend the basis to include additional vectors. The extended basis may contain up to n plus 1 vectors, but no more. To maintain linear independence, the additional vectors form a supplementary basis. Finite dimensional versus infinite dimensional spaces. A vector space is finite dimensional if it has a finite basis. Example includes R power n, where n is a positive integer. An infinite dimensional vector space has an infinite basis, such as the space of all polynomials. Let us know the applications in linear algebra. Bases and dimensions are fundamental concepts used in solving systems of linear equations. They help determine the number of solutions and the dimension of the solution space. Eigenvalues and eigenvectors, essential in diagonalizing matrices, also rely on bases and dimensions. And also, let us know about the application in computer science. Vector spaces and their dimensions find applications in machine learning algorithms, feature extraction, dimensionality reduction, and clustering algorithms utilize spaces and dimensions. They help in representing and analyzing data in high dimensional spaces. Let us know about the conclusion part. Basis and dimension are a key concepts in understanding the structure and properties of vector spaces. A basis is a set of vectors that spans the entire space and is linearly independent. The dimension of a vector space is the number of vectors in its basis. Thank you.